Another important application of proportions is percentages, or you could even think of percentages as a special kind of proportion. All right, so let's say I wanted to know what percent of 24 8 is, right? So if I want, and this could be, say, for instance, there are 8 out of a group of 24 wore green today. So you want to know what percent are wearing green today. Well, this can be found out very simply as a proportion if you think of percent as simply out of 100. And that comes straight from the word percent. Per is, well, per, and then cent, well, that's, as we know, with 100 cents in a dollar, or 100 soldiers under a centurion, or 100 years in a century. This comes from the Latin words centum, which, so it's per 100. Okay. All right. So then we can continue just as normal with these. This is I'm going to actually reduce this first, I guess, just to be simple here. And I can reduce that further, can't I? So let's find out what percent of 24 8 is. Yes. All right. So we have a reduction. Makes a lot of sense here. Yes. 100 times 1/3 equals x. So 33 1/3 equals x. So that is to say 8 is 33 1/3% of 24. Now, if we're going to be dealing with percents, which are really a fraction out of 100 or a proportion out of 100, why not use the decimal system? After all, 100 is a power of 10, right? So to take an example of, 14% means 14 out of 100, which is 14 100ths in our nice little handy decimal notation, right? So that's interesting. That allows us to do some percent problems in a nice simple algebraic form. For example, let's take the example of we want to know what percent of 64 16 is. Well, is like a multiplication. It's indicating multiplication in a way, right? If you say 1/2 of, you can go and multiply that number by 1/2 and get your answer, right? So let's think of it this way. What percentage times 64 gives me 16? And here we have a simple one-step algebraic problem, right? Okay, so divide by 64. So you do that division, you get 0.25 or 25%. So let's solve a problem using both methods, the proportions method and the decimal method. First off, 13 out of the 65 people in the building are wearing Christmas sweaters. What percent of the group is that? Well, if we're going to look at it as proportions, we have 13 over 65 equals what over 100? Okay, you could actually reduce over here, so that's not bad. It turns out this is 1/5. And then multiply both sides by 100. If you didn't see that you could reduce over here, you could certainly do the arithmetic over here with the 13 and the 65, and it would all come out in the end. But that's all right. We can do this quickly. All right. So we have 100 times 1/5 equals x. Okay. Well, 1/5 of 100 is 20 equals x, which is 20%. All right. Now let's solve this problem using our algebra. Right? What percent of, or what number times 65 is 13. Of is times and is equals. Dividing by 65, we get 0.2 in this case. We're looking at this as a decimal, right? So 0.2 represents, as before, 20%. All right, so here's one for you to try. Perhaps pause the video, give it a try, and let's see how you do. So first I'll do this as a proportion and then do it with our algebra. Either method will do. So we're looking at this way. 84 out of 96 equals x over 100. I won't reduce this time just for the sake of seeing how that rolls. So I could do some reducing over here. So here I'm just going to use my calculator to make life simple. Have 8,400 divided by 96. Get 87.5. So 87.5%. Now for doing this in decimal form, what percent of 96 is 84? Again, divide by 96 on both sides. Do that division. Get n equals 0.875 or 87.5%. And of course, this whole idea of using percentages equation or as a decimal can be used to find the percents of numbers as well. So say, for instance, I wanted to know what number is 75% of 84. Well, I can do this just as easily. As I could do this. And they both give us the same answer. That's 21, right? Well, 21 times 3 or 63, right? And similarly here, perhaps we could do some canceling to make our life simpler. That's 3 over 4. 21 times 3 is 63. So there we have it.